Well, you're looking at lesson 8.2 today, and 8.2 only. Okay? Yes, in the notes, it says 8.2 and 8.3 are together, but I am breaking them apart, and we are only doing 8.2. Okay, now, we're only doing 8.2. 8.2, all we have to do is get through the 4 graphs on the front page, and we have completed 8.2. Yes, we will be getting through 8.2 today, and which means your 8.2 homework will be due tomorrow. We're going the 8.2 notes today. 8.3 will be tomorrow. The rest is 8.3. Excuse me. Okay. So, lesson 8.2 is talking about graphing rational functions. Now, when we talk about graphing rational functions, we actually graphed rational functions yesterday. When we graphed those inverse variations, you remember the inverse variations? The 2 curves going out from each other? Those were rational functions. We can also call them reciprocal functions. When x is in that denominator, they are also reciprocal functions. So you'll notice here where it says a rational function, I also wrote in the word reciprocal up above. Rational, reciprocal, similar. And it's of the form f of x equals a over x minus h plus k, where x is not equal to h. And it just has that x is not equal to h on there because if x and h are the same, that makes your denominator 0, and hopefully we all remember 0 can't be in the denominator. Okay? Now, I'm going to write off here to the side. This is all based on what I'm going to call the parent function, which is y equals 1 over x. So everything we're doing today is based on the basic graph y equals 1 over x, which is those 2 basic curves. So we're going to work with those two curves, and we're going to use these equations here to do this. Now, as you backtrack to this, a over x minus h plus k. Do you know anything about some of those extra pieces? What'd you say? I'm hearing pieces. I just can't hear.
I just said I picked a really bad day to wear a dress.
Sorry, I couldn't hear it from the back of the classroom, so I kind of must agree with you. It's not going to be good for walking out to the parking lot or wherever after school. So I'd go with both. Okay. Anyways, back to the problem. Maybe not the A, but do you guys know anything about what the H and K are going to do for us? What's going to tell me up or down? Okay, stop. What tells me up or down? Okay, the number added or subtracted at the end, which is the K, is going to tell me how far my graph goes up and down. Does that sound familiar? We've been talking about that, right? How the number added or subtracted at the end of the function moves your graph up or down. Now, I have been writing in here, I've been being a little more official. Moving up and down is the vertical translation, if you will. Because vertical is up and down, correct? Okay, so that plus K tells me how far my graph is moving up or down. What else do you know? What does the H do for me? Left or right. So if you recall, the number added or subtracted directly to the x, so in this case in the denominator, is going to take my graph left or right. So this is what I'm going to call the horizontal translation. Now, what about the A? Do you remember the A?
Yeah.
Can't tell what you guys are saying. I've heard several things, so I can't. No. That was something else. What's that A do in terms of our transformations? Stretch or compress? Or stretch or shrink? Right? Stretch or compress, stretch or shrink. What if A is negative? What's that do? It reflects it, right? So that A can tell us stretch or shrink, or stretch or compress, and reflection. It's not the one that's as obvious, right? So I'm just going to kind of write in here stretch / shrink / reflect. Okay, so what we're going to do is we're going to take these graphs. The stretch, shrink, and reflection we'll get with our XY chart. But then we are actually going to be moving some of them up or down and left or right. Now, a couple of things. We are also going to talk about domain and range. You know domain to be the, what kind of values? X. Domain is X. So the domain of these functions is always going to be, notice it says, all reals except X equals H. Think about these curves, right? We have these two curves that go out from each other. What are they doing in terms of X's? These curves are moving. One's moving infinitely to the left. One's moving infinitely to the right. And they're going infinitely out both ways, right? And so that's why it's all reals. The except is because there is an asymptote in the middle. And that asymptote, we can't touch it or cross it. It doesn't exist. The range, remember range, of course, is our Y values. And the range is similar. Range is as we're going up and down. Well, one of the pieces of the graph goes infinitely up. The other piece goes infinitely down. There's just one spot in the middle that we can't touch. And so it's all reals except Y equals K. We will practice how to answer some domain and range questions, okay? And then we're also going to talk about asymptotes. Okay? Vertical asymptote will always be X equals H. So it's always X equals how far left or right you move. Horizontal asymptote will always be Y equals K. So it's how far, Y equals how far up or down you move. Okay? So we're going to practice with all that along with graphing. So let's look at example 1. Graph each of the following. Identify the asymptotes, domain, and range. Y equals 9 over X. If you wanted to get fancy, and you're trying to say, okay, well, this doesn't match that version up there you told us of the A over X minus H plus K, really, there's just some zeros in there. Because it's just really 9 over X minus 0 and then plus 0. Okay? And the idea here is that this first graph we're going to do, it's not going to move left or right. It's not going to move up or down because there's no plus or minus there. So we're just looking at the graph of 9 over X. Y equals 9 over X. Did we do something like these graphs yesterday? We did. Remember that inverse variation we did? That's essentially what this was. And when we did our XY charts, we didn't think about 9 divided by X equals what? What did we think about? Okay, let me ask it this way. If this is Y equals 9 divided by X, how do I move that X? Multiply. If I multiply it over, this is going to read XY equals 9. And so 9 is like our K value from yesterday, right? It's that constant value. So in this case, we're going to be looking for two numbers that multiply to be 9. Good news, there's not nearly as many numbers as there were yesterday, right? Yesterday we had some bigger numbers and they were harder to come up with all the numbers. So, two numbers that multiply to be 9. What you got for me? 1 and 9. What else? 3 and 3. And? One more? 9 and 1. Now, those are the three sets for one of our curves. What about the other curve? Negatives. How do we multiply to be a positive? Two positives multiply to be a positive, or two negatives, which means we can take each of those three pairs and make them negative. -1, -9, -3, -3, -9, -1. Okay. Shall we graph it? 1, 9. Right 1, up 9. I will say these graphs are 10 lines, so you're one before the line. One before the last line. So right 1, up 9. Right 3, up 3. Right 9, up 1. Now, do you remember the shape these formed yesterday? They formed that curve, right? And you need to just know that's what these graphs are going to look like. They're going to be this curve. If you recall, it's this curve that curves through the 3 dots. In this case, it's 3 dots. And then it's going to run out and along the x-axis and y-axis, both. Okay, it's going to run out and along the x and y-axis. So that's one of those things that the dots themselves, because we're limited on how many pairs of numbers we have, you have to know your knowledge about, oh yeah, this graph is the one that does the curve. Now, you also have, if this piece lies in the upper right quadrant, we also need to land the other piece down in the lower left, in the diagonal quadrant. So we're going to go left 1, down 9. Left 3, down 3. Left 9, down 1. And I have an equivalent graph, yes? Notice I tried very hard to make sure that that 3, 3 point is a curve and not a hard point. Does that make sense? And it's so easy to turn it into a corner instead of a curve, but work to make it a curve, please. Just like you're going to work to make sure that these don't cross the x and y axis, they look like they're just going to run alongside the x and y axis. Okay. Before we move on to the next problem, we've got to talk about asymptotes, domain, and range. Okay. I'm going to just kind of squeeze them down here in the bottom. So I'm going to start with asymptotes. If you don't remember how to spell it, it's up in the directions. It's up at the top. What are my asymptotes here? X and Y axis, yes? Now, I'm going to be a little nitpicky, and I have to do it because Math Excel will. They're going to want to know, they're not going to want you to call them the X and Y axis. They're going to want you to use the equation. So, like if I start with the y-axis, what is the equation of the y-axis? It's a vertical line that cuts through the x-axis at x equals what point? 0. Okay, it's a vertical, and vertical lines are always x equals a number. Because it cuts through the x-axis at 0, the y-axis is called x equals 0. Your vertical asymptote will always be x equals a number. The x-axis is my other asymptote, right? It's a horizontal line that cuts through the y-axis at y equals what value? Y equals 0. So the equation here is y equals 0. So those are your two asymptotes. And I'm pretty sure Math Excel asked for these. Okay? We also need to talk about domain and range. What did it say about domain up at the top of your page? all reals except, it's always going to start that way, x equals h. What was our vertical asymptote? X equals 0. That right there, your vertical asymptote, which is x equals a number, that's our exception. Because it's that asymptote that our domain can't touch. So all reals except x equals 0. That is domain. You might be able to guess range then. So range, my graph is going infinitely up, infinitely down. What's the one y value it can't touch? That asymptote of y equals 0. So all reals except y equals 0. And I will say one thing. Don't ever just tell me all reals except 0. I need all reals except x equals 0 or y equals 0. Notice, domain is x equals a value, right? Because domain is x. Range is y equals a value because range is y. Okay? Okay, let's try another one. Let's look at B. Another, B is a lot like A, but less numbers. It is less numbers, but that's all right. It'll work. We'll make it work. We can always throw fractions in if you want more numbers. Yeah, most people usually decline that. They make it work. And I'll talk about what I mean, though. Okay, so on B, it's y equals 2 over x. So if that's 2 divided by x, you can think of this as xy equals 2, right? So we're always trying to find two numbers that multiply to be whatever that numerator is. In this case, the numerator is 2. So, okay, what multiplies to be 2? One and two, 2 and 1? And that's it, isn't it? Now, if you are really bugged by the fact I only have 2 points to work with here, then okay, what about 4? Half of 4 is 2, correct? So you could use the ordered pair 1/2, 4, or 4, 1/2. Okay, we could, do that with lots of numbers. So now, if we use 1 and 2 and 2 and 1, we also need to consider the negatives, right? 2 negatives multiply by a positive, so -1, -2, -2, -1. Okay, let's graph these. 1, 2 means I'm going to go right 1 up 2. 2, 1 means I'm going right 2 up 1. That's all you got if you want whole number points. Okay, you have to make it work. This is where I say, know the shape of the graph. What is the graph doing? It's going to run alongside the x and y axis that are acting as my asymptotes. And if you think about it, like, I mentioned 4, 1/2. I could put a point there if I wanted more points. I could come up with lots of different fraction answers. If we have that one in the upper right quadrant, we also need the equivalent down below. Left 1 down 2, left 2 down 1. And it looks something like that. Thoughts about asymptotes, domain, and range? Are they the same thing as the last one? We didn't move this left to right or up and down, so aren't my asymptotes still the x and y axis? They are. So asymptotes, the y-axis, which is x equals 0, just like before, and the x-axis, which is y equals 0. And what about domain? Yep. All reals except x equals 0. And range? All reals except y equals 0.
I'm gonna blow away. Like, I'm gonna walk outside and is it really necessary to know the cars?
The wind is a little distracting.
It's called nature.
Okay, guys. 2 more examples. Now, in these next 2 examples, what do we start adding in? H and K values, right? We're going to be moving left, right, up, down. So, let's look at C. You guys have what you need on B? Start looking at C and thinking about identifying what's what. Yes. So what is that x plus 1? That plus 1 is with the x, so it's left or right, opposite the sign, so the plus 1 will mean left 1. I don't really have room to write in there, but I want to write it in there and point it out. And the minus 2 is added or subtracted at the end, and so that is down 2. You act like maybe I've been teaching that for quite a while. It keeps coming back, doesn't it? And every time, I hope you guys are getting better at it. Now, my recommendation. Okay, so there's a couple different ways we could do this, but our graph normally centers at 0, 0, right? Our asymptotes cross through at 0, 0. My recommendation to go left 1, down 2 is that we just take those asymptotes and move them left 1, down 2. That's my recommendation of how we do this. So on the last 2 examples, my vertical asymptote was the y-axis, right? My graph now needs to move left 1. So what do I do with that vertical asymptote? Move it left 1. So these examples down here, you must draw in the asymptotes. You use a dotted line to do that, but you must draw in the asymptotes. So that's how we move the graph left 1. How do we move it down 2? Take the horizontal asymptote and take it down 2. Now, with that in mind, could you go ahead and tell me the equations of your asymptotes? I didn't catch if you got those pieces together. Let me ask this first. Which one's the vertical asymptote? What's that equation? Yeah. It goes through -1 on the x-axis. So the vertical asymptote is x equals -1. Or it's x equals, how far left or right did my graph move? -1. Horizontal asymptote. Normally at 0, where did we take it? Down 2. It crosses through the y-axis, so we're going to say y equals -2. So there you've already got your asymptotes out of the way. We technically could go ahead and do our domain and range if we want. I mean, yes, we still have to get our values and all that, but think about the domain. I'm going to put it down here. What is domain supposed to be? Okay, so it's all reals except, and then it has to be an x value. Where do we get that from? Yeah, it's our h value. It's how far we moved left. So it's all reals except our vertical asymptote. All reals except x equals -1. You see how easy I pulled that together? Once you have the asymptotes, you use those to do your domain and range. So range, according to up above, it's supposed to be all reals except y equals k. In this case, my k value is -2. Because it's all reals except, what value did we move down to? -2. So all reals except y equals -2. Okay, your favorite XY chart of the day. Well, what are we going to need numbers to multiply to be? Anyone got this figured out? 1. Because what number is in my numerator here? 1. In other words, basically, take off the -2, take off the +1, and we are just left with y equals 1 over x. And so when you multiply that x over, I mean, I'm sarcastic in a way because you're going to complain about the graphing, but these are the easiest numbers to find. What multiplies to be 1? 1 times 1. Now, if you're really bugged by the fact that it's 1 point, what about 1/2 times 2? 2 times 1/2. If you want more points, right? 1/4 times 4. 3 times 1/3. Those things all multiply to be 1. You guys just don't want to go fractions. So, okay, if we use +1, we also need to consider -1, -1. Okay? Two numbers multiplying to be a positive. So, let's graph it. Now, when I do 1, 1, I almost forgot, we haven't talked about this. You have two options of how you can do this. You can graph a regular 1, 1, and then what do you have to do? You have to officially translate it, right? You have to translate it left 1, down 2. So you can take those ordered pairs and translate them. Here's what I like to do. Didn't we already move our asymptotes? So normally we would go off of 0, 0. My new 0, 0 are my new asymptotes. So when I say 1, 1, what I like to do is go down to where my new asymptotes are, and from there go right 1, up 1. And that's where my dot ends up. Does that make sense how I'm doing that? Okay. I mean, the other option is go ahead and graph 1, 1, but then when you move it left 1, down 2, you end up exactly where I'm at. Okay. This 1 point, you know the curves we've been making, right? It curves out, and it's going to run along both asymptotes. Can you make it work? Then we also need -1, -1. So from this new centering, go left 1, down 1. Well, and what's happening here, when we had 9 up above, notice the curves were farther away from the center. The smaller that number gets on top, the closer these curves are to that center point. That's what's happening here. Yeah, I mean, I'm going to go with, can I see an attempt? Did you try and make it a curve as opposed to a corner? You know? Because if you tried, you know, I mean, I had 1/3 hour this morning. It flat out turned into a corner. I didn't mean for it to, but then my others were all curves. And so to me, that says attempt, that I knew what the graph looked like. I was trying. I just goofed up on one. And it happens. But as long as they don't all look like you consistently tried to make them all corners, I'll be happy. Okay? Okay. One more. What is the one thing we're adding into D that I haven't done yet? A negative. Which technically that negative means what? A reflection. However, you know where I'm going to worry about the negative? We're going to use it in the XY chart. Because I'm going to put that negative with the 2 when we go to get our XY chart. So you don't actually have to reflect it. It's going to reflect itself when we do the XY chart. Okay, so what are the pieces you see happening here? Okay, this +3 here is up 3. -3 with the X is right 3? Did you say the other one? Okay, now, my opinion, can you graph your asymptotes? If it says to go up 3, what do? Take my horizontal asymptote and write it up 3. Right 3. Take that vertical asymptote and move it. Right 3. So now we've got our new centering point. Can we get our asymptotes out of the way right now? Vertical asymptote. What does my vertical asymptote go through? What number? 3. So the vertical asymptote is going to be not just 3, but X equals 3. Horizontal asymptote. It went up 3, so it is Y equals 3. I'm going to leave a spot to do my XY values. Could we go ahead and get domain and range done? Domain. My graph extends infinitely left and right, so all reals except, what's the one X value we can't have? X equals 3. So all reals except X equals 3. Range. What's the one range value we can't have? Y equals 3. So, all reals except Y equals 3. Okay. Now, if you drop off the +3, you drop off the -3, the part of the equation we have left there is Y equals negative of 2 over X, right? That's what I'm using my XY chart for. Y equals negative of 2 over X. So if you multiply that X over, it is XY equals negative 2. So two numbers that multiply to be negative 2. We just did positive 2 up above, didn't we? So what do we just have to change with negative 2? So in order to multiply again negative, you need a positive negative or negative positive. So I'm going to say 1 and negative 2, 2 and negative 1. I'm also going to say negative 1 positive 2, negative 2 positive 1. You're graphing those dots, right? And then officially those dots would be translated up 3, right 3. However, I like to look at it as we've already done the translation. Okay? So, I like to think from my new asymptotes, right? So right here is my 0, 0 point. It's where my new asymptotes cross. So I'm going to from there go right 1, down 2, right 2, down 1. Draw an appropriate curve. Running along your asymptotes, not a square at the corner. We also have left 1 up 2, left 2 up 1. Again, running along the asymptotes. Okay, guys. Is everyone listening? That is it for lesson 8.2 notes. The rest are lesson 8.3. This means lesson 8.2 homework is due tomorrow. Everyone got that? I know there's confusion because this is 8.2, 8.3 at top. So 8.2 due tomorrow.
For a few end of the day announcements. Don't forget any students interested in going to IB Tech.